Hey, what's up, Chem Peeps? In this video, we're going to continue to work with electron configurations, but this time we're going to make your life a little easier. So we're going to continue to think about where the electrons are at in the electron cloud, but a little bit differently. So as you think about some of the atoms for which you have to describe where their electrons are at, there's a lot of electrons. And so what we're going to do is take a look at what are called noble gas configurations. These are electron configurations that utilizes a noble gas, which has its valence level fully occupied. These are often used to help shorten the electron configurations of those elements that contain large numbers of electrons. Now, we're going to go over some examples in just a moment, but first, some last important information and vocabulary about electron configurations. First, note that as we work with and dive more into the idea of electrons, we'll learn that there are some atoms that gain or lose electrons. And so, what that'll mean is it'll leave us with some atoms or ions that have configurations that are identical to other atoms or ions. And there's a special term for this, isoelectronic. It just means that the two species have the same electron configurations as one another. Again, just introing that here so you're aware of it, and we'll see some examples and talk about this more later. And then finally, and you've been seeing me do this already, keep in mind that the periodic table holds the answer for the order in which electrons fill orbitals. And I encourage you to use it on all tests. Always start with hydrogen and recognize that you're starting at the first main energy level and move through the periods until you arrive at the desired element. Keeping in mind that those periods or rows are the energy levels. All right, so let's do a little bit of practice. I'm going to start with boron. Just like before, I'm going to find where that element is at on the periodic table. And let me first just draw out the standard electron configuration. Start up here at hydrogen, move through the energy levels. 1s2, 2s2, 2p1. Boom. This is the electron configuration for boron in standard notation. Now, boron doesn't have a whole lot of electrons, but we can still shorten it using noble gas notation. Let's think about what the electron configuration for helium would be, which is the noble gas that directly precedes boron. It's right here. If I write out the electron configuration for helium, notice how the first part of boron's electron configuration is the exact same as helium's. And so what we're going to do is instead of writing out the first part of boron's configuration, we can just put helium in brackets and pick up where helium leaves off. 2s2, 2p1. Boom. So, although it doesn't shorten things too much for us with boron, you'll see the power of this type of notation as we move through some elements that have more electrons. All right, let's do fluorine. You're going to find the element on the periodic table. Fluorine is right here. Again, as you think about this in standard notation, it's going to be 1s2. Just count those boxes. 2s2, 2p, 1, 2, 3, 4, 5, 2p5. Let's shorten this though. Let's find the noble gas that directly precedes it right here and recognize that helium has that 1s2 configuration. 1, 2. This part of the fluorine configuration is the same as helium. Whoops, that's helium, not hydrogen. And so we can rewrite the fluorine configuration as helium in brackets and then pick up where we left off. 2s2, 2p5. Woo! Noble gas configurations, making our life a little easier, writing things down a little faster, but it means the same thing. Sodium, dang, 11 total electrons. Here's sodium on the periodic table. Standard notation 1s2, 2s2, oh my, 2p6. And finally, 3s1. Dang. This is sodium's standard configuration. But let's talk about shortening it. Let's find the noble gas that directly precedes sodium. It's neon. And neon has the configuration 1s2, 2s2, 2p6. Wow. Lots of similarities between sodium and neon. And so, to shorten sodium's configuration, we can just put neon in brackets and pick up afterwards 3s1. Whew, what a time saver, right? Finally, vanadium. All right, everybody take a seat. This one's going to take a minute, right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And everybody, hold on. This is the tricky part. Vanadium 3d3. Don't forget, this is still part of the third main energy level. Okay, vanadium. Wow. All right, let's find the noble gas that directly precedes it, argon, and write out the standard configuration for that noble gas. 1s2, 2s2, 2p6, 3s2, 3p6. Dang, argon, right? Notice all of this is the same, taking advantage of that complete valence level. Now we can rewrite vanadium's electron configuration using noble gas notation, keeping in mind that all of this is the same as argon, and then pick up after that. 4s2, 3d3. Whew. All right, that does it for this vid. Y'all have a great day.